And now we're going to look at the equation a equals v squared over r, which is the acceleration an object undergoes when it is moving in a uniform circle. So we're going to assume our object is starting at the top here and moving straight to the right this way. So if we look at our initial conditions in x and y, we have that the initial position x0 is 0, where the initial y position, y0, is actually r, because this is a circle of radius r. We also have that the initial speed in x, ux, will be equal to v here, because it doesn't have any y velocity currently, it is going straight to the side. In y, currently, as we said, it has no y velocity. In terms of acceleration, the x acceleration will be 0. And in y, it will be accelerating straight downwards because, as we've said before, acceleration is towards the center. And we'll just call that a for now. And we're going to let a certain amount of time t pass, delta t. And we're going to put all of this into this beautiful equation right here, which is simply the algebraic equation for a circle, as in the x position plus the y position squared equals the radius squared. So we're going to look at our Suvat equations here. In x, s equals vt, and in y, s equals, since we're always looking at this equation right here. Let's just put that there and move on, or no. So in x, equals v delta t, and in y equals 1/2 a plus r. Since our initial position was r, our position in s will be r minus 1/2 at squared. Let's write this better. So moving on to the next blank slide. In x, we have that x equals v delta t, and y equals r minus 1/2 at squared. So putting this into the circle equation here, v squared delta t squared plus r minus 1/2 at squared, beautiful, equals r squared. Let's simplify by expanding. R squared minus 2r a delta t plus 1/4 a squared delta t to the 4 equals r squared. So we can cancel these r's right here. And we can also, this is squared here, divide by delta t squared. And that becomes a 2. So what do we end up with? V squared minus r a plus 1/4 a squared delta t squared equals 0. So this is where we cheat here a little bit, and we say that this delta t here must be 0 because we're looking at infinitesimal size here. We're only looking at this very short amount of time. So this whole term ends up being 0, and we get that a equals v squared over r as desired. Wow, we did it.